start? Welcome back, students. Last lesson we learned about motion versus time graphs and velocity versus time graphs. This lesson we will learn how to find velocity from a word problem. At the end of the lesson we will have a quiz to test your knowledge. We will be using the equations velocity final equals velocity initial plus acceleration times time. Velocity final squared equals velocity initial squared plus 2 times acceleration times delta x, and delta x equals velocity initial times time plus 1/2 of acceleration times time squared. So, for example, we'll show you how to do this. So, in the problem, Kyle uses a hairband to launch a pencil with an initial velocity of 6 meters per second. If the pencil has an acceleration of negative 2.3 meters per second, how fast will the object be moving after 2 seconds? First, write down all known units of measurement on the side of your paper. The initial velocity is 6 meters per second.
What's the equation? It's V final equals the velocity initial plus the acceleration times the time. So I know the velocity initial you said was 6 meters per second plus the acceleration is minus 0.23 meters per second squared times, you said 2 seconds, right? 2 seconds. Oh my goodness, I need a calculator.
So now first, write down all known units of measurement on the side of your paper. Initial velocity is 6 meters per second. Acceleration is negative 2.3 meters per second squared. And time is 2 seconds. So write the equation as velocity final equals 6 meters per second plus negative 2.3 meters per second squared times 2 seconds.
So it's 6 minus 4.6, so 1.4 meters per second is the final velocity. VF equals.
The correct answer is 1.4 meters per second.
So I got. So I can do that one. Because then they're all squared like the other one.
Now I will show you how to find the answer if you have the final velocity instead of the initial velocity.
Okay.
It takes Bob 5 seconds to stop his car. If the car accelerates at a rate of 4.5 meters per second squared,
is that a negative 4.5? Okay, that makes sense.
the car accelerates at the rate of 4.5 meters per second squared. Because Bob is stopping his car, the final velocity is 0 meters per second. The acceleration is negative 4.5 meters per second. The time is 5 seconds. When you're solving a problem for physics, the value you're trying to solve must always be alone on one side of the equation. So you must write down the equation we talked about.
Okay.
Now subtract 8 times t from one side.
Just make sure you get it right.
Subtract
Okay.
at from both sides.
Okay. So it's 0 equals velocity initial plus minus.
Now remember, you must write down the equation and figure out what equation you're using before you use any of the values.
Okay. So
write down the equation.
Plus minus. So it would be 4. I did. There's the equation right there. So it would be 4.5 meters per second squared times 5 equals VI.
Okay, now
So 4 just what are the math? 4.5 times 5, 25, 22.5. So he started at 22.5 meters per second. Unless my math is off. Is that right? 22.5 meters per
That's
second?
correct, but you should have done the you should have figured out what equation you were using first before you put the values in.
I was using that BI one that we used last time.
Now, for another problem,
Okay.
if Fred throws a rock 30 meters with a deceleration of 3 meters per second squared, what is the initial velocity? I mean,
So say that again. Let me read it. Let me see it.
no,
So Fred throws a rock.
30 meters.
Okay, so I gotta look at the other equation. It's that big long one you had.
I will tell you the equation.
Okay.
So Fred throws a rock 30 meters. So delta x equals 30 meters.
Delta x equals 30 meters. The
And
velocity equals -3 meters per second squared.
now remember, because he throws the rock and it travels for 30 meters, the final velocity is 0 meters per second.
Okay.
So now take this equation and put v initial on one side of the equation.
What's the equation? VF
squared equals vi squared plus 2a delta x.
What's A?
Acceleration.
Okay.
Delta x is displacement. So
So the
first,
velocity final is 0 squared. So 0.
so first subtract a squared. First subtract 2a delta x from both sides. And you get the equation v final squared minus 2a delta x equals v initial squared. Now plug in the values. The v final is 0. Because that's a 0, you can cross out the 0 squared. Now the answer to v
Wait,
initial...
slow down just for a second, please.
Sorry.
So is the square root of 150?
It's the square root of 180.
Is that because 6 times 3 is actually 180?
Yes.
Because I can't do math right now?
Correct.
Okay, I got it. I'm ready for the quiz.
There's one last equation.
Okay.
Bob's tractor moves at 20 meters at an acceleration of 0.5 meter per second squared. If he travels for 30 seconds, what's the initial velocity?
Okay, so I can use this equation.
No, the equation is delta x equals v initial times time plus 1/2 AT squared.
Times squared.
Correct.
Wow. So delta x. So I know delta x is 20 meters. So 20 meters equals, I don't know what the VI initial times time.
The correct answer was 0 meters per second. Because Bob is starting up his tractor,
Oh, okay.
his initial velocity is 0.
I got it.
Now you are ready to take the quiz.
Let us see the quiz. Okay, thanks for writing the equations on there, which I would have forgotten. So the equation is velocity final equals velocity initial, which was 80 meters per second, times acceleration 8 meters per second squared. Times 10. That was easy. This is not easy. So delta x is 50 meters equals velocity You mean right before it hits the ground? Velocity initial is 0. Velocity final is 1/2 9.8 meters per second squared times I don't know the time. Oh, I can wrong equation. Okay, wrong equation. Velocity final, VF equals velocity initial 0 plus 2 times 9.8 meters per second squared times 80. Oh no, 50. 50. So two times acceleration times change x. Give me a calculator. 19.6 times 50. All wrong. No, that was right.